So this is part of a new playlist which eventually I'll finish, hopefully, and it's going to cover every single button in Inventor and what it does, just to give you an idea of what each button does. And we're starting in part mode and the create panel. It's definitely not a full tutorial per button. It's just this is what the button does with a quick demo per button kind of a playlist. And we're going to start with the create panel. This clump of buttons here, you can imagine if I was to do the entire ribbon in one video, it would take ages. So I'm going to break it up per panel and then per environment, and it'll take me a while to finish. Because it's not worth doing a video just for sketch, I'll start with that, right? So on the sketch panel, you've got two buttons, right? You click this little part of the button here and it drops down, and you've got start 2D sketch and start 3D sketch. So what you do is you select this button here, and it throws a few shapes at you, mate, like a 70s disco, throwing shapes at your face. And then you select one of the planes, and that's the start of your 3D model. You can then sketch up something. Eventually, I'll do a playlist with all of these in as well. But then you draw a shape, you put some dimensions on it like so, and you say I want it to be so big, finish the sketch, and then off you trot with doing your 3D commands. Alright, the other button is start a 3D sketch. Now a 3D sketch allows you to draw shapes and lines, arcs and circles that aren't restricted to just a flat face, right? You remember when it threw some shapes at us? It's restricting you to draw on just a flat face. 3D sketch lets you draw all over the shop, mate. You can go up, down, left, right and all over the place. So we can say, give me a spline. Splines are cool, man. And then you can start at the black dot, which is the center of the model, and you can say, read, I want to go up on the blue axis, right? So that's sort of heading up into outer space. And the easiest way to do that is just to click that square there, and then we can go up, and then we can go that way, and then I want to about turn and go that way, and then I want to about turn and go that way, and then click the green tick. And then there's your 3D sketch. So that could be a wire, a pipe, or a tube, or something. I don't know. It could be whatever you want. But it's a 3D sketch, mate. Because that's the difference between a standard sketch and a 3D sketch. Alright. So now that we've got those out of the way, we can now look at all the buttons on the create panel. So we're going to start with Extrude. Extrude is a common feature in pretty much every single 3D modeling application, regardless of who makes it. It takes a closed profile. It doesn't have to be closed though, mate. You can extrude lines and it'll turn them into surfaces. But normally you would extrude a closed profile. So we'll firm this up with some proper sizes. Let's make that 30 by 20. And then what you do is you select extrude. If there's only one profile in your model, the command will automatically pick it up and use it. And then you can say I want to extrude this by, I don't know, 30 mil in both directions. And then click OK. And there's your extrude. Alright, Revolve. Revolve takes a profile and spins it round an axis, mate. This one's pretty nifty. It's good for creating anything that you can sweep around a line to make a solid. That makes no sense. But let's start a new model and I'll show you what I mean. So we can start with all extrudes and revolves have to start with a sketch. You cannot do diddly without a sketch. So we can say, alright, let's draw a line down here by 50, and then we'll go across here, and we'll go up there, and then we'll sort of bend an arc around there, and then we'll go up there like that, and then there to there. And then what we can do is finish the sketch, and then we can say I want to revolve. It automatically picks it up. Don't forget, there's only one thing. And then you can select your axis, pick the center line, right? So you want to revolve it around that line. So it's spinning it. It's spinning this profile around that line. And then there's your revolve. And you can imagine you can do all kinds of funky shapes with that. So that's kind of good. Read. Sweep. Sweep is like an extrude, but whereas extrude takes a flat profile and extrudes it just up or down or mid-plane, it's kind of normal to the sketch. It just goes up or down from the sketch plane and then gives you a solid. Sweep will take a profile, whether it be closed or a line, let's not get into that, and it'll sweep it along a path. So for example, I mean everything's pretty much circular here, so it's not very exciting. Sweep works quite well with 3D sketches. So let's do that, mate. Let's do that. Let's not keep it simple here, because you might want to see some funky stuff. So we'll do a 3D sketch, and we'll spline up here and then along there, and then we'll spline across here we'll go down a bit, and then we'll go along there, and then along there. All right, so that's kind of 3D-ish. So we want to sweep an object along this. This will be the center line of a 3D solid, and we could do that with sweep. So we'll finish the sketch, and what I can do is create a work plane, attach the work plane onto the end of our 3D sketch, and then click the line, and it'll give us a little bit of paper to sketch on at the end of the line. So we can start a 2D sketch. And what you'll find is for pretty much every button that I cover, there is a bit of prep work before you have to get to the button. And that's what we're doing here. So let's just do a 5mm circle, finish that. Right, now we can start the sweep. So what you do is you select sweep, pick up your profile, and then your path is that, and it'll sweep that circle along that path. And then there you go. You click OK, and then there's your swept solid, and it's all adaptive. You can go back to the original 3D sketch and sort of move it like this, and then when you finish it, it'll update the solid, and your sweep is adaptive to the 3D sketch. And if you're wondering how you're all like, how is it like floating around in space like this, and like a tapeworm in the belly of a poor deprived human? Well, I've done a video on that. Just search my channel for how do you 3D orbit, and you'll find out. Right, Loft. Loft is another tricky one. Loft, well, it's not tricky, but it's just it's quite creative. I've done a video just on Loft before. It's called Get Creative with Loft, something like that. I can't remember the exact name of it. It was one of my first ever videos, so excuse the cheesiness and the over enthusiasm displayed in that video. But Loft will take two profiles and blend a shape between them. So let's do a square 100 by 100. All right. You don't have to follow this. All I'm doing is just showing you how the commands work. That's why I'm intentionally not, like, it's not meant to be a tutorial. So we'll go up, we'll do a work plane up by 75, and then sketch on here. So we'll do a squared around. So we're going to blend a square into a circle, and we'll do 40 here. So Loft will take this closed shape and then, not sweep, but it blends a solid between that square and that circle. And then I'll show you. It's probably best just to show you, right? So we'll go Loft, select the square, select the circle, and then that's what we're going to get. And there's different functions inside of Loft. You can pick a center line, and you can morph and blend the shape between different center lines and rails and stuff as it goes between the two. But then there's your squared around type of a thing. Coil is for creating springs and springs. Top of I can't think of anything else you'd use a coil for, but it's quite easy to do. You would just draw your end of the coil. I'm sure there's a name for it, but it's 10 past midnight now, and I ain't thinking of names for things specifically that I can't recall off the top of my head. That's not my forte at this time of night. Right, so we'll put a dimension in here. Let's call it 100, mate. Let's call it 100. Finish that. And Coil works in a similar way to the likes of Revolve. You pick Coil, you need a sketch. It'll just bomb you out if it doesn't find a sketch with a profile in it. And then you pick your axis, so it's going to weave that circle around a center line. So you need to find the appropriate center line, which would be this one here. And then you can define your coil by the coil size tab, and you can specify it in terms of pitch and revolution, revolution and height, so on and so on. So we can say I want to define the coil height in total to be 500 millimeters, and I want 10 revolutions, and then you'll get something like that. And you can put a taper in as well if you want to. You can say taper out by 10 or not at all. Click OK, and then there's your coil, mate. So that's a pretty easy way of creating, like I say, a spring, a suspension spring, any kind of spring that you want. It's not going to move. There are ways of getting it to adapt and compress and decompress, but that requires a bit of jiggery pokery. That's mucho advanced. But guess what, mate? I've already done a video on that as well, man. I've got a back catalogue of 300 videos, man. Go and check them out if you want. Right, so that's Coil. Emboss. Emboss is cool, man. This is for like stamping or engraving text into faces. Not necessarily just that, but that's typically what it's used for. So, like for example, if you want to, if you see this face here, right? It's kind of curved face. You can't sketch on that, mate, because it's not flat, right? Inventor's not going to let you sketch on it. So if you want to put some text engraved into that face, Inventor ain't going to let you do it because it's not a flat face. So you'd use Emboss for something like that. So we'll float a plane, we'll float a work plane, kind of, I don't know, 65 off of the center. We'll put a sketch on here, and we'll draw some text, and we'll engrave some text into the face, and we'll do it properly. So we'll go DFI, and we'll justify that into the center. In terms of size, no idea, mate. Not a clue how big this is going to turn out. Inventor's text editor, oh, that's not bad actually. Yeah, Inventor's text editor is not the best. There is room for improvement with it, but they'll get there eventually with that one. It's fine, does the job. It's just hey, it's not a word processor, is it? So what can you do? Right, so there's our text. The font, I couldn't give a monkey's uncle. And we're going to activate Emboss. So what you do is you pick your profile, which is the text, and then you tell it where you want to engrave it into. Now you can engrave it into the face, or you can emboss from the face. So you can have the text touching the face and then coming out by a set distance, or being engraved into the face. So we can say, right, we want to engrave it by a depth of 1 mil, and then you've got these 3 options here. So we can go engrave from the face, click that arrow there to go that way, and then click OK. And then there you go, it's engraved it into the face by 1 millimeters. Now if you want to double click that emboss, you can do, and you can say emboss from the face, going that way, I think. Nope, we have to go that way. It must have to point towards the face it's going to emboss from, but there you go, now it's embossed off from the face. And yeah, that's embossed. Now it doesn't have to be text, you can emboss any profile. It doesn't have to be text, but it's typically used with Emboss. Right, and then we've got Derive. Derive's a funny one, mate. It's a funny one. It's got many uses, but a lot of those uses have been superseded by new features in Inventor over the years. But just reading the tooltip, it says it creates a part using another Autodesk Inventor part or assembly as the base component, or inserts a pre-existing component into a part file. It's a bit of a riddle, mate. If you're an ex-AutoCAD user, it's like an XREF. You're taking a model that you've already modeled and you're putting it into this new file as a starting point or a reference. So it's almost like skeletal modeling. That's one use for Derive component. And we'll probably, let's just stick with that one for this one. So say you're a company that makes graphics cards, right? All of your graphics cards, they wouldn't be, but just humour me, all of your graphics cards start out from the same PCB board, right? So what I've got is a PCB board which I've previously designed, which is here somewhere. There it is. There's our PCB board. Now what you'd rather avoid doing is a save as every single time you design a new product that needs this PCB board, because you'd have 100, 200 assemblies or 200 parts with a duplicate copy of this same PCB board in. What if you wanted to change the revision on this PCB board and cut a hole through it? You'd have to then do the same thing on 200 parts that you've put this into. So to avoid that, you'd derive it into the parts and you'd get that live link. You make a change to this, and anywhere it's been derived into, those will update. So let's see that happening. So we'll go back to this part file, we'll select Derive, and then you browse to the PCB, and it's importing, it's placing this PCB into our new part file, and then you can pick and choose what entities come along with it, because inside this part there are work planes, there's sketches, there's parameters. You can tell it to look at all the lengths, widths, heights, all the dimensions that make up that PCB. You can import those into this model and then share those dimensions with your new model. So you can do all that kind of stuff, mate. It's you can get quite in depth with it, but that's not what this is for. So you'd click OK. And that PCB, oh, where's the picture gone? That's a sucky, isn't it? Never mind. But yeah, you'd bring the PCB in, and then you'd say, right, let's start a new sketch. And then now you can start designing, you know, all the heat sinks and VRMs and chips and whatnot that are built off of that PCB. So that original PCB is being derived in. You can then start a new model, do the same derive, start another model, do the same derive, and you've got the same PCB imported as an XREF in the kind of way into all of these different models. So then if you were to go back to this and then change the size of it, let's just this possibly could break something, but we'll give it a shot. Let's increase the length. Yeah, that's going to break the image. But then if we go over to this where it's been derived into, you can see it's now got a flash of lightning to say the original's been updated, this needs updating. So we can select that update button there, and it'll update it in every part that that PCB board was derived into. So it's kind of like a part behaving as an assembly using an XREF. That's probably where we should probably end Derive, but that's a use case for Derive. Rib is for creating strengthening beams. I'm wondering if I've got something I can use here. Probably not. No. So we'll have to model up something new for this one as well. Right, so I'm going to jump into a new model, and we're going to start by modeling a box, which I know that's very exciting, but it's a good example for a rib. So let's extrude this up by 100, so 100 by 100 by 100, and then we'll shell this out by 5mm. Okay, so there's our box, right? So I'm going to do a sketch in between there, so that's going through the center, and then we're going to do a line. This is going to be the center line of our strengthening bracket, and we'll go, I don't know, somewhere like that. Okay, so you would put dimensions on that in the real world if this was something you were doing in production, but I ain't just giving you an example of how the command works. So you'd select rib, you'd pick well, it's automatically picked the line up, but then you can define things like the direction of the rib, the shape of the rib, where it's going. So at the moment it's sort of extruding this rib line towards the side of the box, but you can sort of flip it around if you want to. There's all kinds of settings in here. Or you can pick this one here, which is parallel to sketch plane. The first one that we had selected is called normal to the sketch plane. That's why it was going sideways. But if you select this one here, it goes down. So this is typically what you'd use rib for. And then you can expand the size of it like that, so it's a bit more of a strengthening bracket. We're going to say 10mm, going either that way, or that way. You can even have it as a single sort of thin line, finite as they call it, or to next. So that's extruding down, or by a set distance, which would be sort of like 5mm, like that. So it's quite flexible. You can be quite flexible with this, but I'll stick with to next. It would be nice if you had the option of making this into a new solid, but it doesn't appear to be an option. It will join the box, and this will all become one solid body. But there you go. That's rib. That's what rib does. It creates sort of a strengthening bracket based off of a sketch line. Right, and we've got Decal, mate. Decal's really cool. Love Decal, man. It's creating nice fancy pictures. Everyone loves a nice fancy picture. So what we do is let's delete our emboss, and we'll just reuse this plane that we had here. So we can go 2D sketch on that face, and then insert an image, mate. So we need to find an image. Usually decals work best with PNG files, which have got a transparent background of a high quality, something that's not pixelated, something that's not blocky, blurry, and distorted. So PNG files are the best, so you can mask out the background. So here we've got a McLaren logo. Don't ask me why I got a McLaren logo. I don't know why. It was just an image I had. We can click open, and then drop the image in. Holy mother of mercy, that's canny big. Let's drop that down. Oh, I don't need it to be that big, but what we do need is it to be straight, so it looks neat and tidy. And then I can constrain, constrain that to there. That'll do. Right, then we can go into the properties of the image, like that, and then we can use a mask and then set the chroma key to be black, mate, and that's where it masks the background off. Right, finish the sketch. And then decal is where you pick your image and then you tell it to stamp the image against a face. Like that. Boom. Boosh. Smacks it against the face. That now appears in prints, in drawing views, in renders, and it's got the background masked off as well. Let's get rid of this hideous work plane. We don't want that. But yeah, that's a decal. It stamps an image onto a face. You don't have to sketch directly onto the face. It can be floating off of a face, so it'll decal it onto a curved face like that has done. And it works quite well. And the final button on the create panel that we're going to look at today is import. Import will it's like Derive, but it's for other CAD files. So it'll import various CAD files from different CAD systems into your 3D model. So we can select import. This thing here is a SolidWorks part, SLDPRT, but it will search for files of, wow, that's went off the screen, hasn't it? But it'll search for files of CATIA nature, of Pro Engineer, step files, SolidWorks, Solid Edge, loads of different file types. But then you browse to that file, bring it in, and then Inventor activates its AnyCAD system, which is something that's relatively new to Inventor. AnyCAD allows you to import files from another CAD package without having to convert them into Inventor models. So we can just say reference the model rather than convert the model, and it'll import that SolidWorks model, and it'll keep it in as an AnyCAD reference. Basically, the point of that is if you're working with other people who use other CAD systems, then if they edit the original model, your model that you've imported here will update if they update that in SolidWorks, rather than having a complete disconnect via a conversion. So that's nice. That's Inventor's AnyCAD system. It's I've never come across a use case for it yet, but I can see where it would be used. If you've got suppliers sort of sending you over parts from their CAD system, rather than you having to redo conversions, you can just drop the new version of the file into the folder you had the originals in, and it'll just update it straight away. So that's quite nice. That's Inventor's AnyCAD using import. There you go, mate. There's the sketch panel and the create panel as part of our covering all buttons guide in Autodesk Inventor. I hope I can do this in 1 year, because if they add new buttons, that's going to throw it off. It's going to throw it off quite considerably. I'm not sure how long these videos will remain valid for before the panels start changing, but what are you going to do? You just can't, can you? Alright then, that'll do for this one, mate. Thank you very much for watching. I'll see you in the next one. Toodles.